This is a lesson on multiplying polynomials. So here we have a trinomial, degree 2, times trinomial, degree 3. One thing to keep in mind is that if we're multiplying polynomials, the number of terms in the first times the number of terms in the second will tell us how many multiplications we need to do. So if you have 3 terms here and 3 terms here, we're going to have 9 multiplications to do, which is why you can see that there's only one problem on this page. Now, the work isn't necessarily difficult. There's just a lot of it. I will be color-coding. So I'm going to start with my first polynomial and the first term, which is 3x squared. I'm going to multiply that by each of the terms in the second polynomial. I like to call this repeated distribution because after I'm done that, I'm going to do the same thing with the negative 2 and the same thing with the negative 1. So let's start with 3x squared times 7x cubed, and then we'll have 3x squared times negative 2x, and then we'll have 3x squared times 5. Now, some of you are probably saying, why is he writing it out like that? Some people just need to see it broken down. Okay. I'm also going to do the same thing. I'm not going to do the multiplications yet. I'm going to do negative 2x times the 7x to the third. So you're going to see these 3 are going to repeat 3 times. 7x to the third plus negative 2x times negative 2x. Look at that. Plus negative 2x times the positive 5. And then again, same thing for the negative 1 times those. Negative 1 times 7x to the third. Negative 1 times negative 2x. And negative 1 times 5. And like I said, there are definitely ways to make this more efficient. So it seems like, wow, this is a lot of work. There's a lot of writing. But as your skills in multiplying monomials get better, or if they're already really good, you don't have to write this step. You can probably do that part in your head. Like this is going to be 21 x to the 5th. This is going to be negative 6 x to the third. And this is going to be 15x squared. So I'm going to do that out. I'm going to just give myself a little more space here. And then here, I'll do my multiplications here. So I'm going to zoom in a little bit. This is 21x to the 5th. This is negative 6. I guess I don't need that plus negative 6 x cubed. And then this is plus 15x squared. So those are 3 terms in my, at least part of my answer. Here, negative 2 times the 7 is 14, negative 14. And then there's a 1 here, so it's x to the first times x to the third, which is x to the 4th. The next chunk, negative 2 times negative 2 would be positive 4. It's going to be an x squared. And then I'm going to have minus 10x for that piece. And then these 3 are all just going to change signs. So negative 7x cubed plus 2x minus 5. So I have 3 different chunks, which actually are all part of the same answer. Okay. So I'm going to have to write these a little bit smaller. 21x to the 5th minus 6x to the third plus 15x squared minus 14x to the 4th plus 4x squared minus 10x minus 7x to the third plus 2x minus 5. Now that's a lot of stuff, right? But what we're allowed to do is anything that has the same variable with the same exponent, so I see that there's an x to the third here and an x to the third here, I can combine those into one term. So I like to use the highlighter to kind of do that here. There's an x to the third here, and there's an x to the third there. I'm going to look for any squareds. Oh, there's another one here. It looks like there's only one of the x to the fourths and x to the fifths and the constant. But there are two of the linear terms, x to the ones. Okay, and now I can really make this come together. So 21x to the fifth, there are no like terms. Negative 14x to the fourth, there are no like terms. Okay, and notice that I started with the highest degree and I'm working my way down. I just don't go left to right. I'm looking for the highest degree and the next. So after 4 would be the 3's, negative 6 and negative 7 would be negative 13. I'm looking at the squareds. There's a positive 50 and a positive 4. Looking at the x terms, negative 10 and positive 2 is negative 8. And then the minus 5 is by itself. There's my answer for the original problem. Like I said, there is a very good way to streamline this, but I really kind of take our time and really kind of go through each component of the process.